Welcome to class. I'm Mr. Fincher. We will be working today on patterns defined, but I'd like for you to grab a Chromebook at this time. Oh, wait, you have one in your hand. And you need to go to this website, goo.gl/T capital Q G capital X. That's an 09. And play the quiz. See how many you can get done. We'll do about 3 minutes of this. Knock it out. See how good you are at patterns. All right, I hope that gave you a good insight into how you are with this whole idea of a pattern. Let's go ahead and see what our objectives are for today. This is our last unit of pre-calculus. Yay! We will start by checking off, these are the 3 topics, the 3 objectives we expect to finish through this lesson. We're going to use sequence notation to write the terms of a sequence, and we're also going to use summation notation to write sums. We'll also simplify this thing called a factorial. And this is kind of a checklist. We will knock them out one at a time. All right, a sequence. Hopefully you have an idea of a sequence, especially with what you just worked on. But a sequence is an ordered progression of numbers that follows some kind of pattern. There's something that happens from the first to the second to the third. The way it's listed is a sub 1, a sub 2, a sub 3, a sub 4 with commas all in them. And then if you go to the farthest one, it's going to be a sub n. A finite sequence ends. That's what finite means. So an infinite sequence does not end. So that means you might see the ellipses like you see above. That is an infinite sequence, infinite sequence. Examples, we got 5, 10, 15, 20, 20, 30. Or sorry, no 30. 25. That would be a finite sequence. And this would be an infinite sequence. 2, 4, 8, 16, 32, and so on. Also, you can write it like this. 1 over k, where k equals 1, 2, 3, so on. This is an infinite sequence because we have different values for k that we can plug into that little function. All right, let's write the first 4 terms of this sequence. I'm going to have you try this out. Given that n is our number term. So try to get the first 4 terms. Give you 30 seconds. Ready, go. Pause the video. Oh, I forgot to tell you guys. I'm so sorry. You need to... Oh, that's easy. Never mind. Just kidding. A sub 1 is going to be 3 times 1 minus 2. So that's how we evaluate what a sub 1 is. A sub 2 would be 3 times 2 minus 2, and a sub 3 would be 3 times 3 minus 2. A sub 4 would be 3 times 4 minus 2. So 3 minus 2 is 1. This ends up being 4. This ends up being 7. And hopefully you recognize the pattern that you're adding 3 every time. That is our 4 first terms of this sequence. Easy par cheesy. Let's try this out. Write the first 4 terms of this sequence. Well, pause and see if you can figure it out. Give you about 30 seconds to a minute. Try it out. All right, what's interesting about this is we have this guy up here. And what we know is if we plug in a positive number, if we plug in let's plug in 1, we'll get -1. If we plug in 2, when you square a negative number, you get positive. If you plug in 3, back to negative. 4, back to positive. 5, back to negative. So we're having lots of different possibilities. We're back and forth in a negative, positive, negative, positive. So for a sub 1, all that does is dictate the sign. So it's -1 to the first, and then 2 times 1 minus 1. So that is -1 over 1, which is -1. A sub 2, we can plug that in. That'll give us a positive value on top. And then if we plug in 2, we end up with 3. A sub 3, that's negative again, and we have 5. A sub 4, that's positive again, and we have 7. Great work, you guys. Let's move along. Write an expression for the nth term of a sequence. So 3, 7, 10, 15. We need to figure out what is happening here. So we have a couple things that we can work on with this. For this guy, if you see you're adding, I think, what is it, 4 every time? Yeah, 3 to 7, 7 to 11. So we're adding 4. So that we can count kind of like a slope. So a sub n would equal 4n, but that doesn't work. If I plug in 1, I get 4. Well, my first term is 1 less than that. Let's see what would happen if I did that. See if that works. If we plug in if we plug in 2, we should get 7. So 4 times 2 minus 1 is 7. Yes, so it's always 1 less than what it would be if we did 4, 4, 4, 4 every time. All right, checking the next one, I see that there's an alternator there, something that makes it go back and forth. So let's go ahead and fix that. Negative 1 to the n, would that work? If I plugged in 1, would I get negative 1? Yes, okay. But what am I multiplying by every time there? So I got a negative 1 to the n, and then I also have a starting amount. It looks like negative 3. Yeah. So we can rewrite this here as a negative 3. And then what we have to do is like undo, go backwards a little bit. So, because if I plug in 1 here, I'm going to get negative 3. So I want 2 times that. What would happen if I did 2 times that? That would give you 6. If I plugged in 2, that would be 9. Oh, wait, I'm missing the first term. I am so sorry, guys. I was looking at negative 6 as my first term. Whoops. So I guess dividing by 3 would give me, because it was 6, dividing by 3 would get me 2. Let's see if that works. Plug in 1. Those will cancel. But I'll have positive. What if we put a negative here? There are so many different ways to do this. That would counteract the negative there, and then I think I'd be okay. There are some other ways to write this, but we'll just sit tight. That's pretty crazy. Now looking at this, 2, 5, 10, and 17. Are we adding the same every time? We had 3, we had 5, we had 7. That seems like a pattern, but it's not. So 3, 5, 7, and then the distance, I'm seeing it's a pattern because it looks like the distance is 2 there. Now we're going to learn a lot about this later, but this is called a second difference. And this means that this is following a quadratic formula. So a sub n equals n squared, you're never going to guess, plus 1. Let's see if that works. What is 1 squared plus 1? That's 2. What's 2 squared plus 1? That's 5. 3 squared plus 1. So if I gave you 1, 4, 9, and 16, I bet you would have got it. But this is adding 1, so it makes it a little bit trickier. Let's move into series. So a series, let's take a breath. Everybody breathe in and breathe out. Sequences, pretty great, pretty simple, easy to understand. A series is the sum of the first n terms of a sequence. Okay, so if I said, hey, let's add up the first 5 terms, let's add up the first 10 terms, then that would be called a series. The sum of a sequence is a series. So if I'm asking to find the sum of something like this down here, there is this weird symbol in the front, which is this guy. And that's symbol for summation. It actually is sigma in the Greek alphabet. And it's basically, I call it like a switchback. If you've ever been on a mountain hike, you're going here to here to here to here. So you're starting at 1, and then as you go along your path, you get all the way up to whatever number this is. So say this was 6. So you just plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, and you made it to 6, and you stopped. Okay, for this one down below, I'm going to try this first one on the left. So this is a summation from 1 up until 5. So there needs to be 1, 2, 3, 4, and then up to 5. So let's plug it in. If we plug in 1, we get 3. If we plug in 2, we get 6. We plug in 3, we get 9. Plug in 4, we get 12. Plug in 5, we get 15. So the summation of all of those is what we're going to get. So that would be, what's that, 9 plus 9, and then this is plus 27, so it's 18 and 27. What is that, 30, 40, 45? No, that's wrong. Yes, that's right, 45. I'm going to show you at the end of this how to do it in your calculator. I'll see you in the next video.